In topic 4 of chapter 2, we're going to deal with slope and forms of linear equations. There are a number of objectives that we'll pick up, but if you want to pause and read them over, that would be fine. Here we're going to take a look at what we're calling Formula 3, which is the slope formula. When you have two ordered pairs, you put them in this form, and it's y units over x units, rise over run. Now, as we look at this diagram, we see there is a point here, and there is a point there. And if we know the coordinates of those points, putting that into the formula, we'll get rise over run, and that ratio is the slope. We can also pick out the slope sometimes by just physically counting the units, as we've illustrated a few times. So as we look at example 1, let's just go to the whiteboard and put these values into the formula. So this is y sub 2, and this is y sub 1. So that would be a negative 5. Now, minus is in the formula a negative 3. We'll leave it like that for a moment. And then 2 minus a minus 4. So when you have a minus minus, this becomes a plus, as we see now in both cases. So our numerator is going to be a negative 2, and our denominator a positive 6, which reduces to a negative 1/3 as the slope of that first example. And let's check it out here. There it is, negative 1/3. We'll clear it up and we'll do example B. I've checked that I copied it correctly. And let's go to the whiteboard. Now here we have fractions, which we can work with here. So we have a negative 4/3 minus 1. Now I'm going to put that 1 in the form of 3 over 3, so I can work with the fractions a little better. And then for our x units, 1, which is going to be 2 over 2 minus 3 over 2. And now we can do some summary work. The top is going to be a negative 7/3, and our denominator is going to be a negative 1/2. Now here we have complex fractions. So in division of fractions, the rule is negative 7/3 divided by a negative 1/2. And the protocol for that is the first item stays the same, negative. Well, since I'm dividing a negative by a negative, I know this is going to be a positive. So let's take care of all our signs here. So this is going to be 7/3. Change the division to multiplication, and this becomes the reciprocal of what we had there before. So this now becomes 14/3 as our slope. And let's check that out here. Raise it up a little bit. And there is our 14/3. All right, one more. And let's do it together. We have these two ordered pairs, so it's going to be 7 minus 7, 7 minus 7, and then 1 minus a minus 2, which will give us a plus there. Our numerator is 0, our denominator is 3, and when any 0 is divided by any number other than 0, the simplification of it is 0. Here is some background material once again. If we have a horizontal line, we call that formula 5. Y equals B. The slope of that is 0. That was the one we just had. And the vertical line, we use a number 6 for that formula, was x equals A. And that is when you have a number like 7 divided by 0. That simplified is undefined slope. Again, we've covered this before, but review is good. Another formula that we've been calling number 2. Number 1 was standard form. Number 2 was slope-intercept. If we take any of these equations, and generally if we solve for positive y, whatever's in this m position is the slope. So that's what I'm going to do here. And you can do it with me. So a negative 3y. I'm going to transpose this to the other side as a negative 4x plus 12. Now divide everything by a negative 3 because I want a positive y. This now becomes y equals a positive, because negative divided by a negative gives us a positive 4/3 x minus 4. So our slope for that first equation is 4/3, and the y-intercept is negative 4, which would be written as 0, negative 4. Now in this next equation, we have 7y equals, transpose that to the other side is a negative 2x plus 9. Divide both sides by 7. We now get y equals a negative 2/7 x plus 9/7. So our slope in the b equation here is a negative 2/7. Now here, this is a little tricky because there are no y elements. So this is in the form of x equals a. This is a vertical line. It's kind of disguised. You have to be familiar with this. This slope of letter C is going to be undefined. And then here we have y equals 9, which is in the form y equals b, which is 0 slope. Okay. In this background slide, they're giving us chapter and verse of how to solve for the letter y and end up with formula 2, which we're calling the slope-intercept form. Now, if the slope is 0, again, you get y equals b, which is that horizontal line. So officially now introducing the slope-intercept formula, keeping in mind that when you write the form 0, comma b in the equation, you just use the b portion. But when you're defining the y-intercept, you define it as the ordered pair 0, comma b. And there is the formula down at the bottom of the horizontal line, y equals b. Now in example 3, they're going to take the slope-intercept form and show us how to graph once it's in that form. And we'll start off with standard form here. Let me write it out for you. They're going to take the x term, transpose it to the other side. The 6 is already there. Divide everything by -3 to end up with a positive y. So we now have y equals 4/3 x minus 2. Once an equation is in slope-intercept form, the first thing we do is plot the y-intercept, which is -2. So we put a dot on -2. Then there are a couple of ways to do it. I like to do the run first. That would be our denominator. Our numerator, remember, is the rise of the slope. So I would go over 3, 1, 2, 3, mentally put a dot there, and then do the rise of 4. 1, 2, 3, 4. This gives us another point. Now, could you theoretically do the rise first, as they're showing here? Sure. 1, 2, 3, 4, rise, and then do the run. Again, it's how you do it, and you want to get it right. Now, you could also go down 4 and then over left 3. The key is when the graph starts low like this, and as you move to the right, it goes up. This is positive slope. We'll see shortly if the graph starts high on the left and then goes down as you go to the right, that would be negative slope. And remember, horizontal line is 0 slope, vertical line, undefined slope. Again, doing some review and background. Now here they're giving you slope-intercept form. They're giving us, let's go to the whiteboard, 1 point and the slope. So putting that into the equation, we're going to get y equals, our slope now, -3/5. Now you need to put in the x. Students often forget to do that when they have this. And now just the y coordinate, which is a +3. And if we're going to graph that, which I think this is a good chance to practice our skill, and you're going to sketch this in your notes, the protocol would be do the y-intercept first. So that's 1, 2, 3. Put a dot there. Now this is negative slope. So I would go over 5 then. 1, 2, 3, 4, 5, and then up 3. 1, 2, 3. And there's my second point. And then with a line tool, there is the slope. Going through your y-intercept, and to the left 5, that's the run, and then the rise of 3. Let's go back. And we can go down to, I believe they're going to show us how to graph this. There we go. Let's clear it up. And you can see, again, you could go down and over this way. Remember, if the line starts high, and as you go to the right, it drops, that's negative slope. I've seen a few test papers when I go to check it, and with a negative slope, and on their test paper they're putting positive slope. So again, shortcut, if it starts high, goes down as you go to the right, that's negative slope. So if in the example they're calling for positive slope, be sure it starts low and goes up. Could make that error. Try not to. All right, let's go on. Now, another formula that we've mentioned earlier is number 4, kind of a reference number, and where we have one ordered pair, an x and a y, and the slope. So this is called, appropriately, the point slope form of the equation, and it's written here. Include that in your notes. Now, for example 4, we're going to use the point slope form to convert slope and one point eventually into standard form. And let's work that out on the whiteboard. So we start off by substituting the 3 for the slope, and x is in the formula minus now our first member of the ordered pair, -2. Well, there's negative in the formula, so I could put -2 in parentheses, but we know when we have the negative of a negative or the opposite of a negative, this is going to become a +2. And on this side, y minus, and in this case, it would just be the 5, -5. So this is now in point slope form. How do we get it to become standard form? Well, we have to clear parentheses. We get y minus 5 equals 3x plus 6. Now we need to bring our x term over to this side, and that will become a -3x plus y. And we bring our 5 over to this side as a -5 is a +5, and that then becomes 11. Now, as I mentioned earlier, they don't often like to have the a term of this be negative. So if we multiply everything by a -1, changes all the signs, this will become 3x minus y equals a -11. All right, let's go back to our regular board and check it out here. We'll clear it up so it's not too confusing and move it down. And they put it in slope-intercept form. Okay, we didn't do that. We put it in standard form. I guess I misread that. Let's put it in slope-intercept form and go back to the whiteboard. Okay, so here, all we would have to do is bring this back to the other side, and it would be y equals 3x plus 11. Now this is in slope-intercept form. This one's in standard form. Okay, let's check it out. And there we see it. Okay, we're almost finished here. In this example, they're giving us 2 points and want us to first find the slope, then use one of these points to develop the equation in slope-intercept form. This is example 6. All right, let's go to the whiteboard to do this. And we want to keep our values. There we go. Okay. So finding the slope first. So 6 minus a minus 2 is a plus 2. And then 1 minus a minus 3 is a plus 3. So this would be 4. So we have 8 over 4. Our slope is going to be 2. Now we can use either of these points. And by the way, you could also use this formula. Y equals mx plus b. Now we know the slope, so we can do some substitution. The slope is 2. Our x value, let's use this one, is 1. We don't know our b value, but our y value is 6. So this is a kind of another way to do it, and some may prefer this way. So this is going to be 2. I'm going to subtract 2 from both sides. I get then that b is 4. So the equation is y equals 2x plus 4. That was another way of doing it. And let's look down here at the bottom. Y equals 2x plus 4. Now they're showing you using the point slope form. Again, this is just another way of doing it. So for our last slide, sort of a summary of what we've been doing. Standard form, we're calling this formula number 1. Again, doesn't hurt to write it again. Slope-intercept form, we are calling that form number 2. And we had number 3 as the slope formula. And the point slope form, we've been calling that one number 4, just as references. Okay, you'll have your practice and certify. And this one ran a little less than what we've been doing and hopefully helpful to you.